Okay, so power rule, multiply by the power, lower the power. 2x squared minus 3 squared, what do I get? When I multiply it out.
4x squared minus 6.
Times 2. Four x squared, then minus 6x squared minus 6x squared plus 9. Yep.
Isn't it 4x to the 4th instead of
Sorry,
4x
yep.
to the 2nd?
Thank you. So Alex, doing the derivative of the stuff on the right-hand side, what do I get?
16x to the 3rd minus 24x.
Okay. Well then, if I factor out an 8x, because that's what comes out, I get that. So I have this, and I have this. This needs another 4x on it. How and why might we be able to methodically get that?
It's like on the inside, like if you do the power rule on the inside, you get 4x.
So today is chain rule. So she said, we need to do the derivative of the stuff inside. Okay. So if I was to try this problem just as chain rule, I'm going to do the power rule, multiply by the power, lower the power, so from 2 down to 1, and then multiply by the derivative of the junk inside. What's the derivative of 2x squared? 4x. What's the derivative of negative 3? 0. So that's our answer, which is what we got when we multiplied things out as well. Okay. So here's the messy thing that it looks like. It's gross, and I hate this way of writing composites. But if I'm going to do the derivative of that thing, derivative of the outside, leave the inside alone. And then separate from everything else, now multiply by the derivative of the stuff inside. Well,
Why does College Board write like composite?
They don't use, like, I don't see this notation on there at all, but they don't use this one much either. They will be irritating about it. I will show you. But yeah, they don't write fog very often. And when they do, I immediately rewrite it the way I like it. It's an issue. All right, we ready to try one? Some people are still writing. Okay. So, before we start, what is the outside function? Cosine. And the inside function?
Raised to the 4th minus 2.
There we go. Thrilled with the world today, everybody. Okay, so try that. Do the derivative of the outside. giving it like sassy face. Milo, how do I do the derivative of the outside?
It's negative sine of 3x.
So derivative of the outside, leave the inside alone. And then Annika, how do I do the derivative of the inside? 12x to the third. And I kind of recommend rewriting it so that everything is kind of in an order that we usually do. I am concerned that if you leave this as those two things multiplied together, you might bring that 12x cubed into the angle of sine, which is not supposed to be there. Good enough? Question? Because it's going to get fancier, Andy. It always gets fancier. Not too bad yet. Okay, here's the position of a particle is sine 5t minus 3. Find the velocity of the object. Give that a try. Francesca, what do you get?
I got 5 times cosine 5t minus 3.
There's no undo. So you said cosine and 5 times that. So she got the 5 after the fact, but she said it first. Derivative of sine is cosine, leave the inside alone, and then multiply by the derivative of the stuff inside. Good? Okay. How many functions are here? 3? People are agreeing 3? 2? Jeremy, what would the first one be that you're saying?
The cube root.
The cube root. It's gonna be weird. What's the next function that you see? Sine? And then what's the next function?
That's squared quadratic.
So you need to apply chain rule 3 times. See what you get. Francesca's getting a look on her face, she's like, Felipe, what's the derivative, the outermost derivative?
1/3. -2.
Okay, so derivative of the outside, leave the inside alone. Okay. Power. So we multiplied by the power, lowered the power. Now we gotta work our way inside. What's the derivative of the next function? What is the next function? Is it the orange one or the purple one? So how do I do the derivative of sine? Cosine. So I'm,
X squared 2.
okay, one step, derivative of cosine, we leave that inside alone. And then he said, he did the last chain rule. Now the derivative of x squared. And it's gross and it doesn't clean up at all. But just to write it more normally, so we had to do power rule, derivative of trig, and then power rule again. And even though when Felipe did this derivative down here, like power rule moved it to the denominator, you're multiplying by the derivative. It's up top. Unless it was multiplying by 1/x, then it's gonna end up lower. Yep.
You started on the outside and like worked into it.
It's like unwrapping a present. You take off the ribbon, take off the wrapping paper, and then you open the box. Yeah.
Wait, so could you do this with like 4 or 5? Like,
You could go for a very long
oh
time.
no.
So this, you were asking about how do they do the composite functions? They just smush them all in there and they say,
Yeah.
roar. Okay.
This looks like a joy to do.
Well, it's not bad. It's good stuff. Okay. Just a note on the top module, I have there's probably more of these in the second semester, but I have a few derivative pattern worksheets, and they all look like this, or not worksheets, but cheat sheets. Just here are all the derivative patterns that you might find useful and a ton that you won't find useful. And they're all written like this. So pick a trig function, your favorite trig function.
Secant square.
Oh, secant. I was gonna say it's always sine, but no, he tricked me. So if I wanted to do the derivative of secant to the, 7th, this is saying do the power rule, multiply by the power, lower the power, and leave that guy unchanged. And this means do the chain rule. Now do the derivative of the stuff inside with respect to x. And the derivative of secant, he picked it, not me.
Tan x secant x.
Tan x secant x. And I have to say secant tangent because secant sucks, puts itself in its own derivative and brings the friend. Which friend? The friend that's in the trig identity with him. So this cleans up a little. I blame him. He picked it. It was supposed to be sine. It was supposed to be pretty. Look at him. What do you do? So there's a cheat sheet out there that says, oh, and they're all written with u's in them, and u is a function of x. Okay, and now something completely different. Those of you who had AB or IBSL last year, you have not done this. We're going to find derivatives of parametrics. This will come back in chapter 10. Why it's here and now, really, it's not hard. I don't know. Do you guys remember those? Those were like the projectiles. Oh, you're serving a volleyball and you hit it at 5 feet in the air and gravity's working and, okay. No, maybe not. If I wanted the slope of this line at any point in time that was defined parametrically, it's in terms of time. I still want the slope. What do we use, what letters do we use for the slope in our regular Cartesian plane? What?
X and Y.
X and Y, so I still want dy dx. And it's a problem because my functions are now in terms of time. Okay, so,
Would it be dy dt?
well, this would be dy dt. And this one would be dx dt. I still need to know how is y changing, how is x changing. But what is dy dt divided by dx dt? Well, dividing by a fraction is multiplying by it flipped. And this derivative thing that we've always treated as a function in itself is now just a plain old fraction. And look at that, we get dy dx, which as a matter of fact is how we would do the slope. And I don't want to do the derivative of this one. But here you go. dy dx is just changing y with respect to time over changing x with respect to time. In this homework, please do not use x prime and y prime, because y prime, it's vague. Do you mean dy dx or do you mean dy dt? Use both letters. I'll hand back your quizzes soon. I let a lot of questionable / incredibly offensive and sometimes flat out wrong notation fly, and some of them were just too offensive that I was like, oh, no. But I will try to give you warnings rather than penalize you immediately of like, nah, you need to clean this up. So previous test, y prime was fine, I understood what that meant, but when there's parametrics out there, dy dt, or is it dy dx, which one are we doing? So, if this is my x and that's my y, how do you find dy dt? And that's what I was looking for. Yes, pray to pass. Just take it. Sam, what would you do?
So dy over dt is 10t, and then I got dx over dt, which is just 3, and then dy over dx would be 10/3 t.
And I always write it the way he said. I find, like, I declared what x's equation was first, but I do dy dt, and immediately under it I do dx dt, and I put a little fraction bar. This is what it is. Good? Yep.
Is that how you want us to write it?
My big restriction or request is that you keep a dt, dy dt. What are you doing the derivative with respect to? And then at the end, like, writing it out like this is just, your answer is right here.
Okay.
You're done.
Yeah.
And I find when people solve like, oh, well, dx dt is 3, and this one is 10t. Sometimes they leave it like this, which is wrong.
Yeah.
So just a warning. Okay, happiness and joy. Find the tangent line of this parametrically defined function that has trig in it. Ooh la la. And this is one of those, there are shorter ways, there are longer ways. That equation, this equation, just add down, 3a's go away fast. Yeah, sticky poop. Is, I mean, you got there, Jesus.
Okay. Yeah.
And you made an arithmetic mistake in the process. Joel, can you put up what you would do? Sorry, it's just here who's on top. Are too minimalist in what you favor, like. Oh, it's not right. Oh, you gotta use the other side of the pen because the point part that makes sense is the wrong one. See? How dumb. So like, oh, this is like,
Yeah. I wasn't sure what I was supposed to do.
well, I was kind of looking for like this.
Okay.
And then you can just plug it in and get numbers.
Thank you.
I mean, it worked, but yeah.
Next time I will.
Okay. And
And I'll try to show more. That's the issues. Or do I?
and just welcome to calculus. You don't need to brush these anyways. Yes. What is the derivative of the top? Well, the derivative of the top is f prime, period. Because the derivative of one goes away. Right? And so this is d, but this one, the derivative of the bottom is g prime of x plus 3. And I apologize in advance. Cosine t, I put it on a quiz and I did not use parentheses and kids were like, cost function, when did we start doing finance? And they started freaking out. So sorry. Cosine parentheses t. They were like, what? This class is impossible. impossible. We've never done this. Okay, so all this work, all right. So right here, thank you very much. And we didn't finish yet, but he's simplifying trig over here, which cool. And we didn't have to, because it asked us, I mean, lovely, but it asked us, what is the slope of this at time equals pi over 4? And personally, I find it easier to plug in right here. What is secant of t? Root 2. Sorry, secant of pi over 4. Root 2. What is tangent of pi over 4? 1. Did I answer the question? I didn't let Yoav finish, but did we answer the question?
Like y minus 1 is equal to root 2 times x minus root 2.
Y minus the y value equals slope times x minus the x value. Yep. Okay, and tomorrow is a shortened day, and I want to make sure that we get to whatever questions you guys have on FEMA. Were there questions on last night's homework?
Yes. Can you go over 27?
Yeah, 27 was a pain because you didn't know chain rule yet.
Yeah, I was gonna say that.
Okay, so first derivative, and check that out. The variable was theta, so I'm not doing dy dx, I'm doing dy d theta, and it's a big deal if you say the wrong one. First times the derivative of the second, plus the second times the derivative of the first, which is times 1, and I'm not going to write that. Okay. Double derivative. First times the derivative of the second, plus the second times the derivative of the first, and then plus the derivative of tangent. Okay. The derivative of this. The derivative of this product. First times the derivative of the second, plus second times the derivative of the first. Sorry. It's gross. But that ends up being secant squared tangent twice. Plus those guys. But now that we know chain rule, let's check. First times the derivative of the second. Okay, I'm going to multiply by the power, lower the power, and then multiply by the derivative of secant. Secant sucks, puts itself in its own derivative, brings a friend. And now the derivative of tangent. Oops, sorry. And then the derivative of secant squared times the derivative of the first plus derivative of tangent. You get, okay. Are you okay with it doing chain rule?
Mostly.
Mostly, okay. Sorry.
What?
So that's the mess that's there. It got big, but that's because I had to do it the old school way. Any other issues on the homework? Some of them are funky and tricky, like 21 is kind of gross. They're asking you with this equation, which is written down here. What's the equation of the tangent line at where it's horizontal and at that little other spot? You're supposed to do the derivatives of both and plug some numbers in.
Which is Nice and beautiful.
Yeah, the horizontal's not so bad. Okay, well. This was 28 that evidently a lot of people asked about, which is why I have the work shown already.
You say it wouldn't be differentiable, right? Or there's no value of E that makes it continuous and differentiable.
Correct.
Yeah.
Is it continuous? Well, let's see. If B is 1, it would be continuous, but if B is 1, then the derivative doesn't work out. Well, any which way, whatever B was, it wouldn't work. Here are the problems that are on tonight's if you wanted to start.